Hey guys, Buildzoid here, and today we're going to be taking a look at the new DDR5 refresh modes that are being added to AM5 motherboards. So far I've seen the settings for these on Asus and Gigabyte boards. They should be coming soon to MSI, and I don't know about ASRock. Anyway, for this video I'm using an Asus Crosshair X870E Hero, which was provided by Asus, so big thank you to them for providing the motherboard. And the BIOS version that I'm on right now is 2004, and that uses AGSA 1.3.0.0. The memory kit that I'm using here is a G.Skill 6000 CL28 Expo memory kit, which was provided by G.Skill, so big thank you to them for the memory. And with that out of the way, let's get into it. So, here in DRAM timing control on Asus boards, we have this new setting called bank refresh mode. And so this isn't the actual refresh functionality itself, because that's built into the AGSA. This just allows you to change which refresh mode is being used. Now, when AM5 launched until very recently, it just used normal mode, which is basically DDR4 style refreshing, where if you want to refresh the memory, you need to refresh all of the memory banks at the same time, which basically means that you're refreshing an entire rank of memory at a time, and that makes it completely inaccessible for the duration of your TRFC. So, not really ideal from a performance perspective. And for that reason, with DDR5, fine granularity refresh mode was introduced. And Intel has supported fine granularity refresh mode literally since Z690 launch. AMD has only just added FGR support very recently. 1.3.0 is the AGSA where it's really going, I guess, mainstream, you could say, but it's been kind of available on some earlier AGSA versions in beta BIOSes as well. But anyway, so what fine granularity refresh mode does is it allows the memory controller to, instead of refreshing all of the memory banks at the same time, to just refresh the same bank across all of the bank groups. And since each bank group has 4 memory banks in it, same bank refresh effectively allows the memory controller to refresh just 1/4 of the memory at a time, leaving the other 3/4 still potentially accessible for reads and writes. Meaning that, in theory, fine granularity refresh mode should deliver better performance in certain scenarios, as we will find out. Now, the main thing that with fine granularity refresh mode is that, so the main thing with fine granularity refresh mode, other than the, how it works, what its behavior is that it uses different refresh timings, and it uses some refresh timings differently. And then finally, we have mixed mode, which basically is the memory controller switching between normal mode and fine granularity refresh mode on the fly, based on what the memory controller thinks is best for the current load scenario. And mixed mode basically is like a better fine granularity refresh mode in terms of performance. And we will be looking at how these different modes perform. But the first thing we're going to look at is how they interact with the memory timings, because that has apparently been causing issues, because apparently some Expo DDR5 kits do not have their TRFC timings set correctly. And so the AGSA update, which I've been told that the AGSA is supposed to be defaulting to FGR mode for default refresh behavior now. Some memory kits don't have their Expo timings or XMP timings set properly to function in FGR mode, and that causes systems to not post. But anyway, we're first going to take a look at normal mode, which is how things have been working so far. And in normal mode, the only timings that are used are TRFC1 and the refresh interval timing. And that means we can do things like setting TRFC1 to, say, 400, and then we can just set whatever value we like for TRFC2 and TRFC same bank. TRFC2 is the all-bank refresh setting for fine granularity refresh mode, and TRFC same bank is the refresh cycle for the same bank across the different bank groups. Anyway, so now we're going to save and reset, and this is just going to fire right up, because the other 2 timings aren't used, but then I'm going to switch it to FGR, and it's going to fail to post, because FGR uses TRFC2 and TRFC same bank. So basically, if you have a memory kit where if you're on the latest BIOSes and like I don't know if there's anywhere in the BIOS that'll like directly tell you which mode you're in if you don't have the setting available. But basically, if you like suddenly a system where previously Expo worked, it stops working. It's probably because of TRFC2 and TRFC same bank not being set correctly. So yeah, in normal mode, this fires right up because TRFC2 and TRFC same bank don't do anything. So now if we switch to fine granularity refresh, it's just going to fail to post, which is going to take a little while. So yeah, now we're in memory training. This is going to take longer because it's not going to work. Okay, there we go. And now we should get, like, luckily this is one scenario where safe boot does work. So the automatic, like, failed memory overclock recovery does work if you set your TRFCs badly. Because you'll get this, like, failure to boot. Though I'm not sure if that's true. Like, if the issue with that automatic overclock, like, failure recovery thing is that it doesn't always work on every BIOS version from every motherboard vendor. So it works here on this motherboard right now. It doesn't mean it'll work on a future BIOS update. Hopefully it will, but yeah. Just like you can't rely on that functionality actually working, unfortunately. Anyway, so in fine grain, in FGR, I'm just going to call it FGR because otherwise I'm going to call it fine grain refresh mode, which is not what it's called. But anyway, so in FGR, TRFC1 is not used. And instead, just TRFC2 and TRFC same bank are used. So we're going to set them to like 400 and 300, and this is going to fire up. And there we go. So that's working as expected. And now you might think that mixed mode, which is switching between normal mode refreshing and FGR mode refreshing, would use TRFC1, except it doesn't. So even this is still going to fire right up. Now, the significant difference between mixed mode, or well, from a performance perspective, the main difference between FGR and normal mode as well as mixed mode, or well, the performance behavior of mixed mode is dependent on this. But so the main difference between normal mode and FGR, other than the fact that they use different TRFC values in the BIOS, is that the refresh interval for FGR is divided by 2. And that's not that the setting is divided, that doesn't mean you can set refresh interval twice as high. It means whatever you punch in for your refresh interval gets cut in half. So if you set it to 65,000, it's actually just 32,000. And consequently, when you're on Expo and the motherboard defaults to FGR mode, if the motherboard defaults to FGR mode, Asus auto mode is actually mixed mode. But if your motherboard is defaulting to FGR mode, which is what the AGSA, default AGSA behavior is supposed to be according to what I've been told, this has performance consequences. Because, yeah, your refresh interval does get divided in half, and at Expo, your refresh interval is already very low. Mind you, that getting divided by 2 for the refresh interval, that is JDEC spec. So that's how it's supposed to work. So, yeah, it's just kind of yeah, that's how it's supposed to work. Anyway, we're going to take a look at what kind of performance consequences this has very shortly. So this is just going to fire right up. Wait, we already went over mixed mode. Yeah. Actually, so at this point, we kind of don't need to be in the BIOS anymore. Instead, let's take a look at a lovely spreadsheet. There we go. So I've done quite a bit of testing. I did some testing with single rank 5 Hynix 16 gigabit M die. And the idea for testing with that memory chip is that I know for a fact that it does really low TRFC same bank. So it allows me to exaggerate some of the performance impacts of FGR and mixed mode, even though it's not really relevant to most users because honestly, if you're on AM5, you probably want 24 gigabit M die, which has basically nothing in common with 16 gigabit M die. And you want 16 gigabit A die, which is the same thing. It has basically nothing in common with 16 gigabit M die. But anyway, we'll get to the overclocking settings later. First, let's take a look at how Expo interacts with the new refresh modes. So, auto on Asus is mixed mode, and we can tell because the performance for them is the same, right? So in TimeSpy CPU test, same. Y-Cruncher 2.5 billion, same. PyPrime 4 billion, same. Geekbench 3 memory test, same. 3D Mark 11 physics, the same. Clambench, I call it Clambench. The actual program name is Micro Benchmarks GUI, and yeah, but it's a nice synthetic memory test. Anyway, read test in that, the same. Latency test, the same. So yeah, auto on Asus is mixed mode, which I'm not sure if that specifically happens if you enable Expo or if that happens all the time. But from a performance perspective, this is a good thing because the alternatives of both normal mode and FGR are just slower. They're just slower in different ways. So, if we compare normal mode and FGR, in TimeSpy, FGR has a slight performance edge. In Y-Cruncher, FGR is worse. And both of them are way worse than mixed mode. And there's a reason for why that's happening, and we'll get to that. Anyway, PyPrime, FGR actually has a slight edge over normal mode, but it's still behind mixed mode. Then Geekbench 3 memory, FGR is just worse in Geekbench 3 memory than normal mode, but they're both worse than mixed. Then we have 3D Mark 11 physics, where FGR is slightly faster, but both of them are still slower than mixed mode. Clambench, memory bandwidth, we see that FGR is worse for memory bandwidth than normal mode, but in latency tests, FGR is better than normal mode, which makes sense, because the whole point of FGR is that you're not going to have that scenario where the whole memory rank becomes inaccessible as often as you do in normal mode. Normal mode, every time there's a refresh, the whole memory rank is just inaccessible. You can't read, you can't write. So it's oh, you really want to read something right now? Well, you can't. You need to wait for TRFC1 clock cycles before you can read anything. And so that means normal mode generally has worst case scenario for latency in normal mode is kind of worse, especially because normal mode uses a much higher TRFC value than TRFC2. And this is just mind you, these timings right here, this isn't G.Skill doing anything with the Expo profile. This is just JDEC values scaled up to DDR5 6000. So anyway, basically, FGR is a little bit latency biased across the board and loses any benchmark that is bandwidth biased. So Geekbench 3 memory, the Geekbench 3 memory test, this is basically a memory bandwidth test. And FGR loses it. Meanwhile, PyPrime is very much a memory latency test. FGR wins that. It loses Y-Cruncher, which is notorious for being basically a pure memory bandwidth test. And it wins 3D Mark TimeSpy, which I'd consider this kind of a mixed test. It really scales with kind of everything, but apparently it maybe skews a little bit more towards memory latency than just sheer bandwidth, because otherwise I wouldn't be expecting FGR to win, because FGR is, from a bandwidth perspective, is horrendous. And that's because it's been so much, it's refreshing far more frequently. It's just that, you're more likely to get lucky and have accessible banks with FGR mode, whereas with normal mode, it's nah, the whole thing gets blocked. Anyway, and so that's kind of the difference. Is FGR skews towards latency, and normal mode skews towards memory bandwidth. But these differences, once the refresh interval gets a lot higher, things kind of level out. Anyway, mixed mode is just better than both of these by a pretty substantial margin when you're using Expo timings, and there's a very simple reason for that. Mixed mode is switching between normal and FGR refreshing, so sometimes mixed mode is using that TREFI divided by 2, or at least it should be, as far as I know. I don't know the exact specifics of how AMD has it implemented, but when it switches to normal mode, it definitely uses a full-length refresh interval. However, it doesn't use TRFC1. And that means that when mixed mode goes into normal mode refreshing, it uses TRFC2, which is way shorter than TRFC1 is, and that's why mixed mode is always faster. It doesn't specifically bias towards bandwidth or latency. Like, it's kind of misusing the memory timings, right? Like, if within my understanding of the JEDEC spec, like switching which refresh mode DDR5 is in on the fly is entirely supported by the spec. But within my understanding of the spec, you should probably be using TRFC1 when you're in normal mode, and it just doesn't. So yeah, that's why mixed mode has such a massive performance advantage when you're using expo timings, because it's just like, not only do you have that added flexibility of not having to refresh an entire rank at a time, you have just a way shorter refresh cycle when you're in normal mode. And yeah, as long as the memory controller is doing a good job of switching between the modes as necessary, then it's just going to have a performance edge, and that's what we see. Now, when you start overclocking, things really level out a lot, because as it turns out, when your refresh interval is 65,000 clock cycles instead of 11,000 clock cycles, it kind of doesn't really matter that much how long your refresh cycles actually are. Even FGR is just not that bad once you set refresh interval to 65,000, unless you do something dumb like setting all of your TRFCs to the same thing, which is a thing I regularly see from Intel users, which is stupid because Intel defaults to FGR and has always defaulted to FGR. And I've also seen people do that with the new AMD AGSAs, and it's like, I mean, you're not losing a ton of performance, but it's still stupid. Just don't do that. Now, admittedly, with Hynix ADI, 16 gigabit ADI, you're not gonna get such massive differences in terms of what TRFC values you can run. For ADI, I think it's gonna be 400, 300, or maybe 400, 280 or something. But with 16 gigabit MDI, you can run TRFC SB super duper low, right? 224 is not even minimized. I think I did try 180 and that doesn't post, but I think maybe 216 or something might actually still be viable, which is honestly kind of crazy. But anyway, so what you'll notice, if you set FGR and you just set all of your timings you don't care about performance, then what you end up with is marginal, FGR is marginally slower than, well, actually normal mode and mixed mode, right? What? Wait, you won't let me do that if I merge these? Oh, that is so stupid. Can I unmerge them? Okay, there we go. Because yeah, I really want to be able to shuffle these around. Anyway, so if we put these next to each other, you'll notice that, actually I'll put it here, right? So it's worse than mixed mode, and it's worth noting that with mixed mode, the priority is that TRFC same bank timing. TRFC2, you can see right here, right? I tested TRFC2 equal to TRFC1 and TRFC SB low, or TRFC2 low and TRFC2 low. And I also tested mixed mode where everything is horrible, and mixed mode does a better job of that than FGR, because in FGR, your refresh interval is always being divided by 2, whereas in mixed mode, it's only sometimes being divided by 2. But anyway, so yeah, if you run mixed mode badly, then it still kind of loses some benchmarks, right? In PyPrime, it's just kind of horrible compared to normal mode or mixed mode with the timings set properly. In fact, mixed mode with the timings set properly really seems to be the best thing you can do. Though again, it will depend on the memory chips that you're using and how big the gap between TRFC same bank and TRFC 1 or TRFC 2 are. Right, if you have a memory chip where TRFC same bank and TRFC 2 are basically the same thing, mixed mode isn't really going to do much. And you may as well just use normal mode unless TRFC 1 is incredibly high for some reason, which is actually a weird thing with Hynix MDI, 16 gigabit MDI specifically, where it's it really kind of doesn't make sense that TRFC 1 would be so much worse. It probably is using fundamentally different refresh logic within the memory chip or something, because unlike ADI, TRFC1 and TRFC2 are the same thing, and as far as I know on 24 gigabit MDI, they're also the same thing, as far as how low you can push them. But anyway, yeah, so FGR set really badly is just like, yeah, it just loses everything. It doesn't lose by a huge margin. It's like not as bad as it is at Expo, or, you know, I did tests where I have refresh interval set intentionally very low to exaggerate the effects of the refresh cycle itself. And here, yeah, like if you set FGR to, well, I didn't even test FGR set to 480 because even with the timing set properly, it's already really bad. And so if you did this and like mixed mode with everything set to 480 at 12,000, refresh interval is horrendous. Compared to like normal mode with, you know, 12,000 refresh interval. So you can just imagine what FGR would be like. It would just be a complete disaster because you're dividing the refresh interval by 2 and the timings are, and the TRFCs are terrible. But anyway, so yeah, badly tuned mixed mode is not great. Properly tuned mixed mode is probably the fastest thing you can run right now. Again, within, like, you know, there's some, depends kind of on what memory chip you're running. FGR is like just generally not good because of the whole, like, it divides the refresh interval by 2 thing going on. And then normal mode is still perfectly viable. Like, honestly, if you don't want to deal with this, you could just like find where your motherboard allows you to set normal, like enable normal refresh mode again, and just use that. Also, I think with multi-rank setups, there might be slightly different performance behavior. Like in dual rank, normal mode might... Well, I'm not sure because this is something... I tried checking the documentation, but I didn't really spend enough time searching through the documentation to like find the definitive answer. But I think that in normal mode, when a refresh command is set, it actually refreshes all of the memory ranks, not just one memory rank. But I'm not 100% certain about that. I think for DDR4 it worked that way. This is like, unfortunately, it's really easy to get information for memory timings for a like how it behaves within one memory chip, but once you get to like multi-rank setups, it kind of becomes difficult to find, or at least I've been having a hell of a time trying to find answers for how a multi-rank setup gets its refreshes done. Anyway, yeah, so the conclusion here is basically you should probably not use FGR. Like ever, because mixed mode is just better if you set it up correct. Like, well, mixed mode or normal mode are just better, and mixed mode can be better than normal mode if you, like, if the timings work out. It's not even like obviously if you don't tune your mixed mode, then it's going to be bad. But the point I'm trying to get at is like with the timings work out, it's like depending on the memory chip, normal mode might actually be better if there's not enough of a difference between TRFC2 and TRFC same bank when you're in mixed mode. So yeah, because as you like, you can, you know, I didn't go through all the different benchmarks, but like mixed mode does actually kind of like, it's not even, well, yeah, no, it slightly wins almost everything, except memory bandwidth down here. Or wait, does it? No. Well, it almost wins that. Yeah, so it still has a slight memory bandwidth disadvantage, I guess. But everywhere else, it is perfectly capable of just being faster than normal mode. So, yeah, that's it for the video. Hopefully you find this somewhat useful. Obviously, I'm going to be doing more testing on this because now I'm like very interested in like just how low can you push TRFC same bank on, you know, more relevant memory chips that aren't 16 gigabit MDI, because that's obviously like the deciding factor for like, hey, should you use mixed mode or normal mode? And if it turns out that basically only MDI does TRFC same bank that so low that it's actually viable, then yeah, you can just stick to normal mode. Though even normal mode, like, you know, even compared to like perfectly tuned, well, this isn't perfectly tuned, but like, you know, this also isn't, like dialed in mixed mode compared to dialed in normal mode is not actually that much of a difference. It's very marginal. So yeah, I think for the most part, it's just like, just use normal. Like if you're on Expo, use mixed mode because it's just better in that scenario. But if you're, you know, setting your refresh interval really high and you don't really want to deal with tuning TRFC2 and TRFC same bank yourself, then just use normal mode. because it's not really that different from mixed. Dialed in mixed can have an edge. So yeah, anyway, that's actually it for the video. So thank you for watching. Like, share, subscribe. And if you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And I think at this point, I'll just hit the stop button. So thanks for watching and goodbye.